The colliding black holes that produce these gravitational waves created a violent storm in the fabric of space and time.
This is the Sherlock Holmes quote, right? Once you've eliminated the impossible, whatever remains, no matter how improbable, has got to be the truth. And so we're eliminating the impossible, especially for something this big. You would say, what if we're wrong? What if it's a mistake?
When you're detecting something or claiming to detect something that's never been seen before, you have to have a certain degree of certainty. If this was the 10th event we were seeing, maybe we wouldn't care so much. We know they're out there, maybe we can live with it,
Most of us have heard about Hubble Space Telescope, or giant mountain telescope that scientists use to pointing toward the sky, looking at stars, galaxies, and planets. But what's with this telescope? This telescope uses light to detect things. So with this telescope, we have to rely on light to know what is happening in the outer space. But here's something really exciting. There is a new kind of observatory on Earth called LIGO, and it doesn't look at light at all.
The magic to do that is that if you measure the size of something, you're measuring some absolute size. Interferometry measures the difference in two distances.
So we have a pair of mirrors that are 4 kilometers apart. The gravitational wave has changed the way you measure space between those two objects. It has distorted the space.
They send laser light into the interferometer, and that light bounces back and forth in airs. But if they change their length for any reason, including the passage of the gravitational wave, then that leaks a little light through onto these in-vacuum photodiodes, and that's where we can read out the signal.
So the thing is, I've been working with telescope data for space situational awareness, or the optical image, spectral frequency, redshift, blue shift, but I've never had this thing called LIGO. So instead of light, what's LIGO does what instead of looking, it listens to the universe, but not through sound, but through the stretches and squeezes in the universe itself. What does this mean? Some of the biggest events in space, like two black holes smashing into each other, don't really shine because black holes are black, really dark, and they don't give off any light so that we can see. So before, we only guess these events were happening by noticing how the nearby stars or gases move. But when black holes collide, they shake the very fabric of space by sending tiny ripples across the universe called gravitational-wave.
Gravitational waves are really hard to understand because there's no, what's the medium? What's the thing that's not like water waves or sound waves or propagated through air? It's literally space itself that's fluctuating. And it turns out that space is really stiff. So you need a really big force to be able to get that space to jiggle back and forth to ripple.
LIGO can feed these ripples when they pass through the Earth. Even though the collisions happens billions of light years away, it's like two people clap their hands across the massive ponds and you can feel the faintest ripples across your feet. So here is where it gets really exciting. In 2015, LIGO's computers pick up a signal.
No one else is on site. Unknown to them, at 4:50 a.m. Louisiana time, the LIGO computers register a spike in data coming from both detectors. And an algorithm developed over more than a decade for just this purpose sends out an email alert to only a handful of the data analysts.
Basically, there was email alerts out by the algorithm itself, basically automated, saying, look, something interesting. Marco looks at it and goes, wow, this is significant. This is a very loud trigger, as we call it.
The pattern was so perfect that the scientists couldn't believe it at first. They didn't jump up and celebrate. Instead, they were anxious, nervous, checking everything again and again. Could this really be the first detections of gravitational wave?
When I saw this email, I kind of woke up instantly. It was kind of so beautiful that it was hard to believe it's true. LIGO is a discovery instrument. It looks at this unexplored side of the universe, and therefore it's absolutely necessary to look for something surprising.
It's so nice looking, but we're so skeptical. We of course worry that we're being pranked or tested somehow, but it really, really looks nice. So it would have to be malign, I would think.
So for months, they recheck, retest, and trying to prove things wrong.
This is the Sherlock Holmes quote, right? Once you've eliminated the impossible, whatever remains, no matter how improbable, has got to be the truth. And so we're eliminating the...
Until they couldn't anymore. It was real. So it was the first ever detections of gravitational wave by LIGOs due to two black holes colliding billions of years away. So when I watched this documentary, sitting there and eating my dinner, I feel that same anxiety, the same thrill. It was so exciting to knowing that these scientists just opened an entirely new window on the universe, not just seeing, but feeling the space itself move. It was a kind of discovery that made you sit back and head raising and thinking, it's wonderful.